There just doesn't seem to be a good way to end that music. I'd like to welcome everybody back to our last set of research and academic projects in our showcase today. My name is Lisa K. Schweier, and I am the program manager for the Traffic 21 and the Mobility 21 University Transportation Center. The Mobility 21 team is a collaboration among Carnegie Mellon University, the University of Pennsylvania, the Ohio State University, and the Community College of Allegheny County. Tackling the multifaceted nature of Mobility 21 objectives requires coordinated technology and policy activities and is supported by researchers spanning multiple disciplines: engineering, computer science and robotics, public policy, urban design, information systems, and data analytics. The Deployment Partner Consortium that's associated with the University Transportation Center has affiliates represented by public agencies, nonprofit organizations, public sector companies, and other research institutions. We also have a distinguished advisory council of national leaders that help provide strategic guidance in council. We will be hearing from, let me put this on the screen, 4 different presentations today. Carlee Benhart is going to be sharing about the Women in Transportation Fellowship. Rachel Burcin is going to be sharing about the Emerging Scholars in Robotics. Jhonnes Bates will be sharing about the F-110th Autonomous Racing Community competitions and the courses. And Justin Starr is going to be talking about the Virtual Racing League. I would like to thank all of these people for being here today and being willing to share their information. We will be having breakout sessions at the end where we can spend more time talking in smaller groups. But to get us started off, I'm going to ask Carlee to go ahead and share her screen and to kick us off talking about the Women in Transportation Fellowship. Thanks, Carlee.
Thank you, Lisa K. Can everyone see my screen? All right, fantastic. So my name is Carlee Benhart Kukula. I am the 2019 Traffic 21 Women in Transportation Fellow here at CMU. I am a second year MS PPM student for people who are not aware of the tracks at Hines College. That stands for Public Policy and Management. I also have been working at Robotics LLC as a policy and communications partner. Before I was at CMU, I went to Indiana University of Pennsylvania for regional planning with a land use cartography concentration. My work has been in several areas dealing with equity. So I've worked on projects regarding housing, planning, transportation, and now education. And I'm very interested in accessibility and communications. So the fellowship that I got, the Traffic 21 Women in Transportation Fellowship, is awarded each year to an incoming female student to Hines College, and it is for students who have demonstrated an interest and a commitment to intelligent transportation systems. So some of my work in the fellowship has been with the Smart Mobility Connection series, which you may have heard about if you were here for the end of the last session. But the Smart Mobility Connection series is a series of talks that occur on some Fridays where students and faculty conducting transportation-related research in data analytics, robotics, public policy, engineering, architecture, and design, and any other transportation-related topics speak to the university, the community, fellow faculty, and one of the really exciting things about the Smart Mobility Connections is that They've actually been more popular than ever since COVID hit, because before we used to be constrained by the physical size of the room that we were in, which held about 40 people, but we would often have up to 60 people try to come into the room because they were so excited about the talks. Now regularly we get over 100 up for each talk, asking questions, and it's a fantastic way to bring together the university and the greater community. Also a great way to see some really exciting transportation research. Additionally, as part of my fellowship, I am involved in Transportation Club. I am the Transportation Club president this year. And because CMU, for whatever reason, doesn't have a transportation related major, the Transportation Club does the connecting work for students all over Carnegie Mellon University. It's fairly unique in that it is a university-wide club, so we have people from all different kinds of colleges, undergraduate and graduate, and we connect those people with activities relating to transportations. In pre-COVID times, we did field trips. We're slated to have a field trip to go to Cranberry Township's Traffic Information Center, I believe with Sean Chen, right after spring break of last year. And we have career panels. I think Transportation Club is a really fun and interesting aspect of this fellowship because you do get to reach out to people. I think one of the main benefits of this fellowship in general is that through the Smart Mobility Connections, you get to reach out to some of the researchers, and through Transportation Club, you get to reach out to not only the people in the CMU community, the students, but you also get to reach out to people who are working with transportation related jobs in the larger Pittsburgh community, which is so exciting. Additionally, I was very lucky to be able to have an internship this past summer that allowed me to kind of connect some of the things that I'm interested in with transportation and with equity, and also bring in some new passions, including equity and education. Because I interned at Robotics, a company that usually works with robotics problems and route planning problems, but in light of COVID, the Pennsylvania Department of Education actually reached out to Robotics and asked them to help develop some robotics-related mathematics content for high school mathematics learners. So I came on the project last summer in June, and I was part of the team for outreach to try to get the materials that we had made for free available to our Pennsylvanian students and the teachers in our classrooms. And that gave me a variety of new and exciting opportunities. I got to meet a lot of really cool people on both the activist and education side of ed tech. I was able to make a couple of presentations, and I continue to work with Robotics because I had such an exciting opportunity there. I really felt that it was an amazing fit with my equity focus, and was so excited to continue the work. Thank you guys so much. I am open after all of these sessions come together for any questions that you may have, and I hope you have a great day.
Thank you so much, Carlee, for sharing your experience as the Women in Transportation Fellow, and I'm sure there will be more questions later. Next up, Johan, we'd like to have you talk about the F-110th autonomous racing. If you would like to go ahead and share your screen.
Hi, everyone. You can hear me?
We can hear you.
So, hi, everyone. First of all, I wanted to introduce myself. My name is Jhonnes Bates, and I'm a postdoctoral researcher here at University of Pennsylvania under the supervision of Professor Mangharam. And today I want to give you a short introduction about F-110, autonomous racing, about the community we set up, the courses we teach, and the competitions we have. So first of all, what is F-110? F-110 is a low-cost open source platform for autonomous driving, especially for machine learning engineering on perception, planning, and control. You see here a picture of the car. It's a 1/10 scale, and we have different parts on this car: an RGBD camera, a LiDAR, Wi-Fi setup where we can access the car, and the central part is an ECU, the NVIDIA Jetson TX2. So first of all, how do we build this car? So it's very easy to build because we are relying on a chassis design from an RC controlled car called Traxxas. You can buy that online. And then we develop different parts like different mounts for different sensors, a power board, which is capable of distributing the complete energy to the individual sensors. And last but not least, the NVIDIA Jetson TX2 ECU. This is an embedded ECU that not only includes a CPU, but also GPU, so we can have accelerated deep learning algorithms on this platform. In addition, we can change the sensors, like we have stereo camera here, and we can apply a mono camera there, and we can therefore have the complete portfolio of an autonomous driving vehicle. To complete this, we are relying on the software architecture in ROS. So we are accessing the complete community in ROS, which is providing algorithms in the field perception, planning, and control. And with that, we can enable our research. So what we did with that, we set up a complete course here at Penn. In this course, students can learn about autonomous driving in a theoretical way. So we teach them the algorithms, all you need to know, and then they can apply it to the cars. We have here 6 modules listed. We start with a really smooth introduction about ROS, about robotics, and about a simulator. Then we really fast bring the students to work with the car itself. Then we step in module C, where we teach them about mapping and localization. And the more advanced stuff comes in the end, like the path planning with MPC or reinforcement learning in the learning and vision part. And with these different modules, the students learn more and more how to handle autonomous driving vehicles. We also developed an F-110 simulator. It's a lightweight 2D simulator built in ROS, which displays all the students need to see, like the walls or the car itself and the path the car is exploring. And what we did achieve with that we bring the students to combine the knowledge from a theoretical way to deploying it to real hardware. And the learning outcome is that they understand the real world difference and the influences to the algorithms. So they apply something in a simulator, they see it works, they apply to the car, they see it does not work. Why? So they had to figure out the hardware a little bit more. And this transition gives the students a very good feeling about the complete autonomous driving stack development. In addition, we providing different races. First of all, for the students, at the end of the course, they have a race. And in the last 4 years, we had different races starting in 2016 in Pittsburgh, moving to different countries all over the world, like in Seoul or in Sydney, in New York City, or in Berlin in Germany. And with these races, we set up a complete community, which means all over the world, not only students from Penn, but all over the world, there are universities that built this car. They set it up for themselves at their university. They work with the car and they took part in those competitions. And what you can see here, for example, is a video from an onboard camera from our F-110 vehicle, where it's racing at one of the competitions in a head-to-head race against another car. It's really hectic here because it's trying to overtake, and we can see if it's making it. and here it crashed. But yeah, this is the races we can enable with this car. And where does this lead to? First of all, we can teach that to our students, but we want to not have it only at Penn. We want to enable a little bit more. So we are joining forces, for example, with the Indy Autonomous Challenge or with the Autoware Foundation, which means that the Autoware Foundation is developing Autoware for the F-110's car. We are cooperating with the Federal Highway Administration, CAMA. They will use our cars for their development, or with OpenCV, or let's say open source distributions like ROS or OpenCV. This is where we are heading to with this car, and therefore, thank you very much for listening. If you're interested in getting a vehicle kit, you can use this QR code. If you want to build it by yourself, you can get the materials, or if you want to use our code, you're very happy to use that from this GitHub. Thank you very much for listening. I am here for additional questions. Thank you very much.
Thank you so much for sharing about the racing. I know that course looks very familiar. I had come out to the University of Pennsylvania and got to see that in action. It was very cool. I didn't know that there were so many things to do with that flexible hose, but to make all of these racetracks. So very cool.
Yeah. Yeah, thank you very much.
You're welcome. Next up, Justin Starr is going to be telling us about a little bit of a different racing program, the Racing League that they operate at the Community College of Allegheny County. Justin?
Yeah, thank you so much, Lisa Kay. Hi, everyone. Happy Friday. I used to ask people how they're doing, but lately, since March, I haven't got good answers, so I don't really do that anymore. But my name's Justin Starr. I'm an assistant professor at CCAC, and I'm here with one of my colleagues, Robert Szymanski, to talk about our approach to a virtual racing league, which is a little bit different than the one y'all just heard about. So we're focusing on making something accessible for a 2-year audience. So getting a program where we can take students who want to be automotive technicians and expose them to some of this content in a way that they can digest some of the basics of math and AI without going too heavy on the math. So our idea is we have a strong automotive technologies program, we have a strong mechatronics program, and we know that intelligent transportation systems are impacting our graduates' abilities to get jobs, right? When they're going to work at a Ford dealership doing automotive service, or they go to work for Tesla, they need to know the basics of computer vision, they need to know AI, they need to know what LiDAR is and how to read sensor data, and it's starting to be a different world. So we created an experimental course this past spring to try and give them some hands-on experience building an AI platform using physical remote-controlled cars. And as you might guess, that did not go very well because March, the world changed completely and the class shut down because of COVID-19. We moved online, but it really wasn't the same. So we kind of got our heads together, and the person who's here presenting with me, Rob Szymanski, is a CCAC alum who actually went to work at NREC for CMU. And Rob had a great idea that if you're here, Rob, if you want to kind of talk about your thought process, that'd be perfect.
Yeah, absolutely. Can you guys hear me?
Yes.
Okay, so good afternoon, everybody. I'm Rob Szymanski, and like Justin said, I am a former NREC intern as well as a alumni from the mechatronics program here at CCAC. And during my internship at the National Robotics Engineering Center, we actually worked on a competition to bring together employees based off of autonomous RC races. And at the time, back in March, they had been running a couple races at NVIDIA at their national conference, doing a big race and everything, until they all got canceled due to COVID-19. So when this all happened, we were forced to shift gears and go into a simulated RC car race. And so what we did is moving into the donkey car platform. We actually took what they had started in doing a virtual racing league out in the West Coast and started to implement this for our own students to train them. So we used the donkey framework, which was based around an open platform for autonomous RC vehicles. And the great thing about the donkey car is you could pretty much use any platform and start plugging and playing with a Raspberry Pi or an NVIDIA Jetson Nano and start interacting with the code. And the good was it's all an open source library, so students can add and contribute to these repositories or do projects for the college to really kind of further their learning. And the great thing is that the donkey car enables you to build a self-driving RC car and operate it teleremotely, as well as train an AI model very quickly and easily. But since we can't do the physical cars, we were forced to do a simulated version instead. Now, the donkey gym in AI simulator creates a wrapper around the donkey simulator so that it pulls what would be the simulated camera feed instead of the actual camera feed of the RC car. Using the simulated camera feed to pull data as well as the local steering angle and throttle positions, you're able to collect this information to train your own AI model. So, and then once these AI models are trained, you're able to connect these over a network and send your cars to a server to actually compete these cars against each other, these AI models against each other.
So it was amazing, right? Rob was like a blessing from wherever you believe in, right? He stumbled back to CCAC and wanted to share all of this wisdom. We cobbled together enough hardware to make it work, right? We got this discarded HP Pro Liant, which made it through. We threw a GPU in there that was good enough, an NVIDIA 1030. We found a switch port on the network that no one was really watching, so we're able to plug in. And the student laptops running Windows 10 were able to support off-the-shelf controllers. So it's not the setup we want to use forever, but we wanted to do a proof of concept to see, was this approachable enough for our two-year students? You know, could they make it work? And the idea was they'd do some manual driving, they'd collect data, they'd build a model, and they'd use that to generate, you know, a neural net pilot that would drive around. And then we had the kids race the pilots and see who was better. So this is an example of what it looks like and what they were able to pull together. You know, you can see it's not working super well, but it was enough to get them the idea of AI and autonomous driving without needing to take a whole semester course. So that was our idea going into it, was to see if we could make this, you know, and put this together. And we actually tested it with a focus group of students this morning, right? Perfect timing. So I had a set of mechatronics apprentices who were actually in an injection molding class, a plastics class, and they took their final exam this morning. And I said, well, if you want 1,000 bonus points, stick around this afternoon and let's see if you can get up to speed with it. So what we found is that these guys, no background in Linux, definitely no background in AI. They could use the donkey car environment in about an hour. They could train models in about 2 hours. And at the end of a 4-hour crash course, they had to earn the 1,000 bonus points. They're actually racing. And it turned out pretty cool. So this is a screenshot from a few hours ago. I had to mute the audio because some of their language was a little coarse, but they're driving around training the system. They figured out how to make it work. It generally was a pretty good success. And then they were able to, you know, produce a model that we recorded, sorry for the shaky cam, on a projector. And that's it, driving by themselves. And they were just stunned that they could do AI, like it suddenly became approachable. And we all know there's a lot more to the story than this, but for a 4-hour workshop to get them interested in AI, we were just pleased with the progress they made. So the students did a fantastic job. Rob helped us put it together. And we're excited in the spring to roll this out into a massive kind of virtual racing league across campuses. So get students from the different CCAC campuses to download Donkey Gym, train some models, upload them to a server. We can have regular campus races. And then when in-person instruction starts again, we can do it on the physical hardware. So that's where we're going with this. You know, if COVID lifts, we can do physical hardware sooner, but it's a nice opportunity for us to bring the campuses together. So any questions, let us know. If you want to race us, we're happy. We brought our A team. So my contact information is there, and thank you guys so much.
You're on mute, Lisa K.
Yes, I thank you. I made it almost the whole day without doing that, but Justin, thank you. And Rob, thank you for adding the information you did and for your help in putting this together. It's pretty interesting. So we're going to move to our last presentation. Beverly and Fausto are going to be talking about their robotics summer institute experience.
Do you want to just give a little bit of an overview of what the RISC program is?
Of course. So let me turn my video on. It's off. Okay. So basically, we spend about 11 weeks working at the different labs or divisions at the Robotics Institute. So I was a special case. I worked under the mechanical engineering department, but they were focused on autonomous vehicles and human-robot interaction that summer. So that's where I did most of my research in, basically with finding ways to overcome ambiguity in robotics, and ambiguity in the sense of predicting things that are not supposed to happen. So the basic example I always give is if you have a robot that's meant to pick up something continuously, it's supposed to be able to detect some child who is not supposed to be there picking the object this robot wants to pick. So that's basically how ambiguity will help solve that issue through learning what an algorithm, which was called the multi-agent deep deterministic policy gradient algorithm at that point. And
hello, can you guys hear me now?
Yeah. Yes,
sorry about that.
Fausto.
It wasn't taking my microphone, but I left and rejoined. So hello, as Beverly said, I also participate in the RISC program. I'm a senior at the University of Nevada, Las Vegas, studying mechanical engineering. So the video I'm going to share now is a quick overview of the RISC program by Miss Rachel Burcin.
Well, actually, Fausto, in a very great forward-thinking move, we had everything preloaded onto our website, so people can go and watch the video, and I will post a link to the site so they can do that.
Mm-hmm.
But I wondered if you or Beverly had any kind of overall thoughts that you wanted to share before we close your part of this section.
Mm-hmm. You could start, Beverly.
So in addition to what I worked on, I would say in general, the RISC program not only gives you a good insight into research in robotics and artificial intelligence, but it also lets you develop core skills. Like we had a lot of talks and presentations that were given to us. Although we didn't have that opportunity of doing lab tours, but we also had virtual lab tours where we had the different mentors come in and tell us about their labs. And we also had a lot of connections with PhD students at the Institute currently, on master students as well as different graduate school insights. Do you have anything to add, Fausto?
Yeah, overall, I'd like to thank Mobility21 for providing a scholarship, for allowing this program as well during the pandemic, as most of the research programs for undergraduates got canceled or rescheduled. So overall, just thank you for the support. And I didn't explain a bit about my project, but my project was more on air traffic control. So it was using like a flight simulator for a collision avoidance system in terms of trying to get more vehicles in the air to autonomously, I guess, navigate across the airspace. But overall, yeah, just thank you for Mobility21 for the support and the partnership with Carnegie Mellon University, and I guess for supporting undergraduate research. Thank you.
Thank you.
Thank you both for being here. Oh, I hear somebody's dog. You know it's a good webinar when you have a dog. Want to thank you for presenting today, and everyone who shared information about their projects and their academic activities at all of the different universities and colleges that we work with. Hi everyone, I see people are coming back from the breakout rooms. How did it go in those smaller discussions?
It went really well. Thank you for giving us the opportunity for a little intimate chat.
You're so welcome. I'm so glad that you all are here today. And what an interesting discussion about two different kinds of racing. I was like, that's pretty cool. That's a lot in a short period of time.
Yeah, we saw that too. We didn't think there'd be another racing league, but there you go. That's what you get. But we're excited. We were thinking of ways they could complement each other already.
Johannes, you see, you're gonna have some connection after this.
That's good. Competition is always good.
Oh boy, we're gonna have the east part of the state and the west part of the state. Well, I'll tell you, I am so grateful to everyone who hung out through the entire Deployment Partner Consortium Symposium. It's hard to believe that we're wrapping this up for 2020. We do this once a year, so you will start to see information and hold the dates probably in the summer for next fall's edition. We also run a Smart Mobility Connections seminar series throughout the spring and the fall semesters that we will make sure to get you information on. If anyone has any final questions before we close the event. Okay, hearing none, I would like to say thank you. Have a wonderful weekend. Enjoy your Thanksgiving, be safe, and I wish you all the best. Thank you.
Thank you, everybody.
Thank you.
Bye.
Bye, Lisa K.